Oh. Oh, I see where it is. Okay.
All right, now how do I hit? Do you have to hit send?
Yes, you have to hit send.
Yeah.
Okay. Where is there's the pointer. Rebound the mic. Where the heck is the? Okay.
Okay, guys, I didn't put my video because I know you really don't need to see my face, right? You are only interested in, I don't want to put too much occupying the space here, so.
Okay.
Sure.
Can everyone hear me?
Yes, I can hear you.
Yep, I can hear you.
That's nice.
Yes, I can.
Okay, what happened? Okay, that is good. So shall we start, or I just want to make sure before I start, you guys all are ready to go for. And where is my assignment? Yeah, here it is. Again, folks, I just want to mention one thing. If you all can hear me, I just now sent an email on problems 4, 5, and 6. Please assume the cells can be empty.
Okay.
Okay. Good.
I am just writing here. You all can see the whiteboard, right?
Yeah. Yep.
Yes.
Okay, that's nice. If you cannot see anything, at least anyone just type it in the chat session so I can see you guys. Now, I am pretty sure people have questions on this assignment. Any particular one you want to start with? Yes, assignment 3 already, yes. Hi, Scott.
Hello, how are you?
Doing great.
Good, good.
Again, today we will talk about assignment 3 mainly. So,
yeah.
Because the due date, that is what is close by. So,
I had a question about number 2.
Okay.
I got an answer, but it just seemed to me like it almost didn't fit. I don't want to say didn't fit with the section, but it seemed like it could have been assigned earlier with the answer I got, and it just made me wonder if I was maybe missing the idea with the internet code word of length 9, and I'm assuming that means we could have repetitions. So it was a permutation, and we had a set of 9 to choose from. And then I believe the problem says we cannot start with 0 or end with 1. And so rather simplistically, I just laid out 9 blanks and had 8 choices 8 choices in the first, 8 choices in the last, and then 9 choices in the 7 in the middle, which gave me 9 to the 7th and times 8 to the 2nd. And it seemed like something we could have done earlier, and maybe that's silly of I just thought maybe I'm missing the idea here.
Yeah, if you do like that, can everybody hear what Valerie said? So what she said is this. I am talking about problem number 2. In this, there are 9 spots we need to fill. Oh, I am sorry. I think that is Nisa, right?
Yes.
Okay, I'm so sorry. 1, 2, 3. Because you didn't say your name, so I.
Sorry.
4, 5, 6, 7, 8, 9. And again, what she said was, you don't want to start with 0 or end with 1. But the way it asked, what she said was she don't want to put 0 and 1 here. She don't want to put 0 and 1 here. So the number of choices we have is A, B, C, D, X, Y, 0, 1, 5. Then she's filling all of them. So there are only 7 choices to fill, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are only 7 choices here, 7 choices here, and there are 9 choices elsewhere. That was the initial thinking. Am I correct? That's
Yes.
what you said. Right?
Yeah, well, actually, I thought there were 8 choices. I thought it just couldn't start with 0. Does it mean it couldn't have either one of those? It can't. I thought it was 8 choices at the beginning and 8 at the end. Maybe I misunderstood the question.
Well, I'm reading it that way too. I see start with 0 or end with 1.
Okay.
See, I can see the confusion. You guys were using inclusive OR. That means you want to eliminate both at the same time. Even this also I am not allowing in this case. So, for example, it cannot start with 0. That means I can have, even I am not, don't want to allow this as well. Okay, man. 1, 2, 3, 4, 5, 6, 7, 8. I don't want to end with 1. So I don't want this also should be there as a part of my answer. So at least the way I was thinking is this. Just hear out. The way I did was, first I calculated all the possible code words. From them, I subtracted the things that start with 0 and also subtracted the things that end with 1.
Okay.
That means total number of code words are 9 over 9, right? That is the total number of code words. From that, if I remove, for example, I don't want my code words to start with 0. So first, find out all the code words that start with 0 and subtract from the total. That will give you the total number of code words that cannot start with 0. So these are the total number of code words. From that, if I remove this, this is the total number of code words that has to start with 0.
Okay. Okay.
Okay.
And then another 9 to
I'm
the
with-
8. And then I see.
And these are the
Yeah.
ones that
End
has to
with
end
1.
with 1. Yes. So this minus this.
Okay.
Should be your answer. And I never thought the way you were saying. I don't think you will get the same answer. I'm pretty sure we are going to miss some the way you were doing.
I see.
I cannot think on the top of my head what are the things we are going to miss. So,
Real quickly.
is this making sense to all of you guys?
Yeah.
Mm-hmm.
Is for me.
That is good.
Yeah, they don't match. The way I was thinking is not the same. So I'm going just 8 to the second does miss something.
Yes,
That
that's
was
what
not a good way.
Yeah, there are too many few passwords in that case.
Right.
Yeah.
Okay.
Okay. Now I'm just waiting if anybody is noting down. So. Okay. Now can I? I'm really struggle with the reading to comprehend.
Hi, it's Val. What I'm struggling with is I read it like you did, Nisa, the same thing. And so I'm trying to figure out when I read that, how do I know in my brain to read it as what you explained?
Yeah, so the most of the times, whenever we use the word or, can I erase this page so that I can explain what Val was asking?
Yes.
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 Thank you. Because the whiteboard, the disadvantage with the whiteboard is that is the reason I always use PowerPoint. I have to erase it. I cannot extend the whiteboard. That is just a pain. Whenever I use the word or, it is almost all the times exclusive or, okay, unless I mention inclusive or. When I use the word A or B, that means it can either A or B or A union. I can take the things which are in common as well. That is all the time. That means if I say I like chocolate or ice cream, means if I want to select people who like chocolate or ice cream, that means the people can like both as well.
Right.
That is normally the definition of or. Sometimes people say inclusive or, then that is another thing. But most of the time, I know what you are saying. But most of the times when I use the word or, almost all the times, you have to remove both of them or one of them as well. So here you are making in this problem too, the way Val was saying is, first she's putting 0 and the last, first she don't want to put 0 and the last she don't want to put and, but the individual choices also we need to count. That means I don't want to have the one with last one, but first is need not be 0. So even the individual things also I need to remove it. So I don't know whether I'm explaining it the way you understood. Am I making any sense, Val?
Yeah. So when I'm reading the problem, the key thing was that the key word is the or.
I agree. So from next time on, I will try to be more explicit. So that you will not be confusion. So I'll say that cannot start with 0, comma, end with 1, or cannot have 0 on the first and 1 in the last. So I will mention specifically like that. Then you will have less confusion.
Okay.
Okay.
Yeah. Okay, that is for 2. Any other questions, guys? I'm pretty sure you have a couple more.
Yeah, let me think.
You know, Nisa was asking about the last question. But before I go all the way there, I just want to make sure you have any things before. 8 at the beginning and as well.
I think there was something in 9.
In 9?
Yeah, I wrote a question that said How can I tell if, okay, I think it's a reading question again. In 9,
Yes, 9, the way they put that is, again, I modeled this question sort of similar from the textbook. So if you look at problem number 9, guys, there are 12 passengers. A train with 12 passengers stops at 4 different stops. So there are 12 passengers. That's what you need to understand.
and I had him as indistinguishable.
Passengers are, in this case, I am only interested in the passengers who are getting off together. That means passengers 1 and 2 get off together is different from 1 and 3. So here passengers are distinguishable, but I don't care about the stops. If you are interested only in the passengers who get off together. Yes, I know. Even the first time I looked at these things, even it is a little bit confusion. I can completely understand.
Because I saw 4 different stops, meaning those were distinguishable stops, but I couldn't tell anything about the passengers, so then I went the other way.
Yes, I modeled the questions from the book. Even initially I thought like this, but then they clearly mentioned if you are interested only in the passengers, that means they are not caring about stops. They are really not caring about the stops. So
I need to relook that one over.
yeah, just let me check. So 4, I can think of this as, say, balls. And 5 stops, these are indistinguishable because I really don't care about the stops. We are interested only in the passengers.
So this is like case 3?
This is like case 3, you are right. And the balls are distinguishable.
Okay.
So now in this case, the cells can be empty because there are some stops people might not have even got down. Man, this is really bad. Even my hands are writing here. So for problem number 9, there are 12 balls which are distinguishable and 5 cells which are indistinguishable, and the cells can be empty because there are some stops people might not even got down. So this is going to be case 3.
If it says 4 different stops, does that mean that it's 4 stops or?
Yes, there are 4 stops. Is that what you were asking?
Yeah, I just want to make sure I wasn't reading it.
Yeah.
You're just
4 cells or 5 cells.
I didn't hear you. Can you say it again?
But you
Well,
wrote
you wrote
5
down
stops down?
5 stops, and the problem only has 4 stops.
Oh, there is a typo in there? Let me check.
I just wanted to make sure I wasn't misunderstanding what I'm doing.
In problem number 9, I am seeing only 4 stops in there. Where did the word 5 came into picture?
I don't know.
There's 5 on your whiteboard.
Yes.
Oh, on my whiteboard. I apologize.
Yes.
Okay.
Man,
now we're
sorry, guys.
That's all right.
Okay, now I'm with you. All right.
So cells can be empty. So this is like, frankly, you have to use this. This is case 3. So yeah, like 12 comma 1. Please don't calculate these values because these are pain in the neck. So don't calculate. Just put it like this and leave it. Making any sense, guys?
Mm-hmm.
Yeah, don't calculate. It goes plus 12 3 plus 12 4.
That's the formula from 52.
Are you talking about, you mean page number 54?
54, yes.
Yeah.
Okay.
Page number 54, case 3A, to be more
3A.
precise. Yes.
Yep.
Okay, yeah.
I'm sorry, let me mute this.
Can I erase this board, guys?
Mm-hmm.
Now, question. Oh, James was asking something. On 13, which passenger and floor, the book says that the 5 floors would be distinguishable. To answer James' question, this is pretty much, James was saying, he is referring to problem number 13 on that section.
Yeah.
This is very much like the same thing, but even if you look at the answer for 13, I think they published it, I guess. They were saying we are only interested in the passengers who got up together. The next sentence is the one which is the key. That means they were saying that I don't care about the which floor you get down.
Mm-hmm.
Page
The
58, Valerie.
Yes, to answer Pam questions, yes, 12.1 also included for theoretical purposes, yes. Yes, James, you're absolutely correct. Here also my assumption is you guys are reading the book as well. So that is the reason I didn't post notes for 3.1 and 3.2 because those are just basic definitions. So what other questions you have on this assignment, guys?
Just 12 for me.
Okay, Nisa was saying 12. So can I assume everybody got 11?
First initial. Must-
All right.
Because problem number 12 is the pigeonhole principle. So here I am assuming everybody understood what pigeonhole principle is. People call that as the shoebox principle, or there are different names for it. For example, if there are 4 pigeons, and say 3 holes, and if pigeonhole principle says if every hole should have a pigeon, then there is at least one hole which has more than one pigeon. That is the pigeonhole principle, right? 3 holes, and you want to put one pigeon in here, one in here, and one in here. So the fourth one has to go either here or here or here. So one of the holes should have at more than one pigeon. That's what the pigeonhole principle is. You're all fine there, right, guys?
Yep.
Yes.
So I just want to make sure that. So for problem number 11, if you want to find the answer for A, I just want to make sure you all got it before I go to 12. You want to find out, you want to select total number of people, so they should have the same initial. 2 people should have the same initial. So how many people I should select?
7.
I'm talking about 11A.
Right.
Yes. 27 makes sense. Everybody agree with 27 as the answer?
Yes.
Because there are 26
Yeah.
initial. So once you have 27
Right.
people, 2 people have no choice. So that is the same logic. So now I am going to go to 12. Now I am going to give you a hint. Those who have the textbook, this is very close to, let me open the textbook. The way you need to model this is, on example 2.34 on page 102. This is very close to that.
Okay.
I'm just giving you a heads up. So whenever you're writing it, once I explain it, you are start going to write on this. So this is very similar to that. This is a pigeonhole principle, but the problem is a little bit difficult than problem number 11. So I'm going to give you explanation, but whenever you're writing your answer, you have to write it by following this example on page 102.
Right.
It's very much verbatim, really.
Okay.
Okay, let us.
All right.
I see.
So let us go to 12 then. See, I will call in this case A1 is total number of games he practices on day 1. And if you do A2, this is total number of games he practices on day 1 and 2 together. Hope you can understand my handwriting here. A3 is the total number of games he practices on day 1, 2, and 3 together. So how many weeks he prepares? He prepares for 11 weeks. That means total he prepares for 77 days. And so you have these with you, A1, A2, A3, blah, 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 A77. These are all the numbers you have with you.
Okay.
Everybody can hear me, guys?
Yeah.
Yes.
And we know that each and every day he practices at least one game. If anybody can't hear me, just type me in the chat session and make sure. And so you know A1 is greater than or equal to 1. And also I can say this. Right, because the total number of games on 2, because I'm including on the previous one as well, so it is keep on increasing. It is
Right.
strictly, this is
Right.
like a proof. Okay. So now you're okay up to so far. and also A1 is greater than or equal to 1 because he plays at least one game. So now I can conclude, and also he says he plays at most 12 games per week. At the most. So total number of games he practices at the most is less than or equal to 11 weeks and 12 days. Sorry, 12 games per week. So total at the most he practices 132 games. Are you okay with this so far, guys?
Mhm.
Okay. So now I'm going to erase this. So I just want to make sure. So far what we have is this. This is proof by contradiction. So we says if you proceed like this, somewhere there should be a screw up. Okay.
it.
Now I want to prove one of these numbers are going, at least two of these numbers is going to be 21. That's what I want to prove. I'm saying this cannot happen. Two of those games have to be 21. So this cannot be strictly increasing. That is what I want to prove. So I will add 21 on both sides. So this is 21 plus 1 is 22. (132) plus 21 is 153. Am I correct?
Mhm.
Okay. Now I am going to write all of them. Now consider, see all these numbers. A1, A2, A3, blah. Man, I'm not able to put down. A77, A1 plus 21, A2 plus 21, and dots. Yes, Val is absolutely correct. And A77 plus 21. And all these numbers, if you look into this, they are between 1 and 153. Are you agree with me, guys?
Yes.
Now, if these numbers are still increasing, as Val suggested, these numbers are also should be strictly increasing, and these all should be different. Am I right, guys? So, how many of these numbers are there? From 1 to 77 and 1 plus 21 to 77 plus 21. So there are total 154 numbers are there. 77 plus 77. I am saying these are 154 numbers, and all these numbers are to be between 1 and 153. Everybody agree with that?
Right.
Yes.
So by pigeonhole principle, at least two of these guys should be equal to each other.
Right.
So I know the first 77 are different from each other. The last 77 are different from each other. So there should be a one guy in here and one guy in here. They should be equal to each other.
Right.
So I'm going to clear this page if that's okay with you.
Yeah.
There must be a number in between A1 and A27 that must be equal to, exactly. That is exactly whatever Val was saying. That is exactly the same thing I'm saying. So there is a number on the first set that should be equal to the number on the second set. So there should be A such that AI is equals to AJ plus 21. I don't care what that I is and what that J is. I should be on the first 77, and these on the, this should be here and this should be here, and I'm saying these two are equal.
Right.
So by pigeonhole principle, everything in the middle also should be equal because this is strictly increasing. Am I correct?
Correct.
So that means I found two numbers. And in fact, at least I can find more than two really. Everything in the middle, because this and these are equal means everything in the middle should be equal to each other. So all the numbers between I and j on the first set. For example, I'll call this as say A75 and this is A2 plus 21. So that means all the numbers in the middle are also equal. So if you take all the numbers between A2 and A75, those also should be equal. That is the pigeonhole principle. This is very much modeled on the example I just now mentioned. You have just different numbers.
Right.
Gotcha. Okay.
Okay. Yeah. Any more questions, guys? Again, I am recording our conversation and I'm going to post our conversation to you tomorrow. So he was talking about, okay, James was asking about problem number 7. So can I erase this, guys?
Yes.
Okay. Let me see. In problem number, yes, yes, James, you're absolutely correct. The same stuff, cells and balls, man. We cannot run away from it. The 5 kinds of misprints. So I'll call this a cell 1, cell 2, cell 3, cell 4, and cell 5. Yeah. Now, how many ways we can find values, right? This is, so there are 12. How many ways we can find 12 misprints? So you can assume one of the print might be a typo and one of the print might be a grammatical mistake and one of this might be some other. So there are 5 kinds of misprints. So I will call this as 5 distinguishable cells. Now I am wondering how many in this 12 can go here, how many different ways I can distribute these 12 into these 5 boxes. Well, it's absolutely right. So 12 indistinguishable balls, because some of them might be typos, into 5 distinguishable cells. And in this case, please remember, cells can be empty. There might be a kind of misprint like a typo you might not even have there. So 12 indistinct, man, my handwriting is atrocious. So, yeah, well, formula is right. So you need to use C of k plus n minus 1 comma n. So if I remember balls and cells right, this is going to be 12 plus 5 minus 1 comma 12. So you don't need to simplify anything, but at least I'll appreciate if you write this answer as yep. Yes, James. Thanks for asking. Yes, sir. Scott, you have any question, man? I haven't asked. I just want to make sure I'm answering all of your questions. Well, any more questions, guys? I'm going to erase this.
Yes, can you hear me?
Yes, sir.
In a problem similar to that, how do you determine when something is distinguishable versus indistinguishable? So I know which case
Yeah.
to use. Because once I know what case and where I'm at, I mean, the formula is pretty, is not difficult.
Yes. See, for example, if you look into this, that depends on what we want. There is no hard and fast rule saying that, okay, follow this algorithm, you will always figure out what is distinguishable, what is indistinguishable. That is a difficulty in this. For example, if you look at problem number 7, normally if you look at a misprint, we might assume for all practical purposes, all misprints are indistinguishable. So one mistake might be on page 1 and one can be on page 2. So those things can happen. So that's what I am saying. For example, say if you look into this problem number 7, in this case, all misprints I am assuming as indistinguishable. But if you look at problem number 8,
Right.
how you going to do about problem number 8? Do you think all the 20 misprints are distinguishable or indistinguishable? What do you think?
I suppose if we do not distinguish the types of misprints. So
yes, Pam is right. Since there are 5 kinds of misprints, so all those 5 are distinguishable. I'm talking about 8. If you go to 8,
right.
there are 20 misprints in 50 pages.
Right.
In problem number 8.
So the misprints then are indistinguishable
Awesome.
because
I am only
And the
interested in how many
pages is distinguishable. Okay.
Yes. Because I want to find out how many mistakes are in page 1, how many mistakes are in page 2. And I really don't care what kind of mistakes they are. I am only interested in. So the pages are distinguishable, absolutely correct. These are distinguishable.
Gotcha.
So it's almost like what you want, that tells you, really. One thing I agree Val was mentioning, and problem number 9, normally if you say 4 different stops, see the wording is confusing. The word different, we immediately by default assume those are distinguishable. But the next sentence simply saying we are interested only in the passengers. We don't care about the stops. That's what they were saying. So to answer your question, there is no rule I can tell you to figure out what is indistinguishable, what is distinguishable. You have to go by the particular problem, really. Hope I didn't confuse you too much.
So for number 8, can we assume that we can have some empty cells? I mean, I guess how do we assume that there's empty cells then?
Here, there is no need for them to specifically. They were saying how many ways we can find. Because see, there are some pages which might not have any typos, right? If there is a typo in each and every page, you will have at least 50 prints, right?
right?
Right.
Yeah.
So there's going to be
even-
some big,
Yeah, there should be some pages. Otherwise, the book is a bad book.
True, true.
The way they should say is if you say if I add one more sentence and saying there should be a misprint on each page, at least one misprint, then you are right. Then there should be at least typo on each page. Then you will say cells cannot be empty. Yes, Val is absolutely correct. Not empty is not possible because there are only 20 misprints in 50 pages. So some of the pages should be nice.
yeah.
If I change it to
Gotcha.
70 misprints and 50 pages and there should be a misprint, at least one misprint on each page, then I have to be that specific. Then you know that at least all the cells are not empty.
Gotcha.
Yeah, cells empty is the most common problem. So cells not empty is very unusual. That is the reason you
Okay.
see that the formulas are a little bit complicated when the cells are not empty. Cells are empty makes more sense. That is much general. Okay. Any more questions, guys? How about 10? What is 10? 6 distinct jobs to 4 workers. So at least one worker. This is cells cannot be empty, right?
Right.
So what do you think for 10? Yeah, I'm not asking you to. Oh,
1B.
is that? Oh, the 2111 is the final number as the answer. Oh, sorry, 3111 is. Oh, answer is that big. Maybe. I haven't calculated the answer. So this is in 2.10. So you will say in this 6 jobs. So maybe I'll call these as balls. And distinct jobs. So these are distinguishable, right?
Mm-hmm.
Mm-hmm.
And 4 workers. So I'm assuming all workers are also different people, right?
Mm-hmm.
And so this should be case 1B. This is case 1B. So that is going to be this is the formula n comma k. You cannot simply have 2 distributions, well, because I don't understand when you're saying 311. When you're saying 311 means that is the final answer you got, or 3 jobs for the first guy and 1 job for the second guy, like that?
Yeah, 3 jobs for one guy, 1 job for each. And I was breaking the jobs down, but I think I.
Yeah, but that is different from first job. This means you're assuming 3 jobs for the first guy. Maybe I'll call this as Mike and I'll call this as John. That should be different from this, right?
Oh, okay.
Because John might have 3 jobs because he will take more money to his house than Mike. So you are, all the workers are different and all the jobs are different. Now, but you want to make sure each and every worker has at least 1 job. So you go to case 1B.
Okay.
N balls into case cells. So balls are balls. 6 comma cells are in this case is 4. That should be the answer. Making sense, guys?
I think so.
Good.
Okay. Sure, Pam. Do you think you can? When is the due date for this assignment?
Saturday.
Saturday.
Do you think you can submit by Monday night, Pam? Do you think Monday night should be okay for you or not? Or you want more time? Sure, okay, that's good. So guys, the due date, a couple of people are asking for an extension, so you can submit up to Monday midnight. When you read 10, okay, let us look into 10. See, at least the jobs are clear cut, right? Distinct jobs. Am I making any sense? So
And
Val is asking about problem number 10. So all the jobs are different. Here, in this case, each and every worker should get at least one job. So that itself will tell you is I'm distinguishing between the worker to worker. For example, as just now mentioned, 3-1-1-1. That means worker 1 got 3 jobs and the rest of them got 1-1-1. That should be different from this, because in this case, this worker is getting more money than this. So these people in this case is different. Most of the times, jobs and people are by default should be different, unless like in problem number 9, where they specifically say I don't care about so and so.
Oh, okay.
Because people are, if even the two people work together, I have to take their work as distinct. To answer well, most of the times the jobs and the workers, the people should always, most of the times, I don't want to say 100%, but most of the times people, if you always deal with people, people are going to be different from one to the other. Whenever you're dealing, that is the reason I didn't put 4 distinct workers. By workers itself, I assumed you all can understand people are different from each other. For jobs, I mentioned 6 distinct jobs. Because the jobs, I want to make sure you understand. Yeah.
Okay. Okay.
Yes. Yes, Val, you are absolutely correct. Sometimes I clearly say don't distinguish. Each family is indistinguishable. That means I'll consider that family as one unit. But unless I specifically say it, people are different from each other. Even twins, even identical twins. Man, I'm so glad I don't have twins. Even one is a pain in the neck.
now for 11B, for
Yes,
the
sir.
same 11B for the same month, we're assuming that all months have 31 days. Are we considering February, or do you want us to do?
See,
I mean,
that's good. When you say month, it really shouldn't
never
matter.
mind. I'm thinking days in the month.
Yeah.
Never mind.
Yeah.
Never mind.
I got it. Yeah.
I got it.
Okay, that's nice. What is quints? I don't know what is a quint.
5.
5.
Oh, 5.
Wow.
Oh my.
Oh my God. Wow. Their mom is Oh my goodness, you can say that again, Pam.
Oh,
Yeah, so when you say 5, still I'll consider them as distinguishable. Because if you feed one, you have to feed the other 4 as well. They don't say I'm full as well. You have to feed
There you go.
all 5 diapers needs to be changed. I cannot change 1 diaper and say I'm done. Yeah. That's
So
good.
in the 5 babies, it makes a difference for the 6 jobs there too.
Yep.
I got it. Yeah.
Yeah, babies makes us more understandable, I guess. So Monday night, even before Monday night, you can submit it. If you want extension, please email me a day before and start reading that 3.1 and 3.2 anytime, Pam. I'm more than happy to help you out. And if you have any questions on that, any topics, please let me know. I'll post one more video this weekend on 3.3 and 3.4.
Great. I'm just swamped with homecoming right now, and it's the game's tomorrow night, and Saturday we have the dance, and then Sunday we have cleanup. So I'm swamped.
Oh, even I have a homecoming night. I don't know when it. I think it is like, man. Yeah, you are involved
I've
then.
done this for. I've done it for 16 years. I'm ready to hand it off to somebody else.
I don't think anybody will take it. I think you pamper everyone too much. Thanks, James.
That's what I'm
Anytime.
afraid of. Yeah, I'm
I
afraid
know.
nobody else is gonna want it. Thank you so
Anytime.
much.
Oh, anytime, guys. If you have any more question, please let me know. I'm assuming I answered all of your questions.
Yes.
Mine.
It's very
Thank
nice
you so
talking to
much.
Thank
you.
you very much. All right. Have a good night.
Thank you, sir.
Have a good
Thanks a lot,
evening.
guys. Sure. I'm going to post this recording sometime tomorrow.
Okay, great.
All right.
Great.